Okay, let's get started. Good morning, good afternoon, and good evening from Helsinki, and welcome to the Pulse of Networks webinar series, episode 18. My name is Claus, and I'm the CEO of Creanord. And today I'm particularly excited because I have my two friends from AVEQ here, Werner and Alexander. Werner is the CEO of AVEQ and Alexander is the CTO. I will let them introduce themselves and AVEQ more in detail a bit later in the presentation. Today we are going to talk about the very hot topic, OTT and social media quality of experience, and how the quality of experience for video relates to customer loyalty. Before we start, I want to advertise that all of our previous episodes in this webinar series are available on our website as well. So if you are interested to look at what other topics we have and look at some earlier topics, check under News and Insights on Demand webinar on the Creanord websites, and you will find the previous episodes there as well. All right, so let's get started. All right, so user experience is on the top of most communication service providers today. So it's no longer about the speed of the communication services. Both fiber, mobile networks are quite fast enough, and getting more speed is only going to improve your experience of the service a small bit. Now it's really about very much the experience of the actual services that you are consuming, web browsing, voice services, video services, very important, and social media, obviously. And particular video and social media are the most important ones. 90% of the traffic in Finland is video, and globally it's something like 70% in the network. So it's really important as a service provider that you understand what is going on in the network. And why is it important? Well, if we look at, for instance, why there's a study from 2022 looking at why customers would choose a specific provider. Now, 41% of the factors were related to the network and the net experience of the network. 38% is price, and 21% some other related factors. Now, if you look again why a customer is leaving his service provider, again 40% is related to the experience of the network. And here only 22%, for instance, is related to price, and then of course customer service and other factors. And if you are looking from the point of view of the Net Promoter Score, how they would talk about the service provider, again almost 40% is related to the network, and then we have the other factors. So in all the three different categories, the network is the key in keeping your customer and getting new customers and having them loyal. So and we at Creanord, we have done some user experience measurements before related to voice, web browsing, and so forth, but we were lacking the video part, and both for OTT and for social media. So I was very happy when I met AVEQ at Mobile World Congress some time ago, and we were talking about integrating the AVEQ technology into our solution. And finally today I'm happy that we now have it available, and that I have Werner and Alexander joining me to talk about why this is really important. So I will now hand it over to Werner and Alexander to continue a bit of why this particular part is so important in today's network.
Yeah, thank you, Claus. Also from my side, Very warm welcome. My name is Werner. I'm AVEQ's CEO and co-founder. And our main slogan is you stream it, we measure it, meaning that whenever you stream a video, be it you're an internet provider who's delivering third-party video services on top of your network, or you're a video provider yourself because you're an ISP who has their own TV service or a streaming provider, we help you measure that. So we historically have always researched video and video QoE. And this has led to our solution being very much about the user experience, where we help internet providers, especially in the German-speaking region, as well as benchmarking and testing equipment vendors to measure and compare QoE for streaming purposes across different ISPs across different countries. So for example, our technology is also used for a benchmarking campaign in the German-speaking region, where there's a magazine that puts out scores saying this ISP is the best for streaming, and these results are quantifiable and they are related to how we do the QE testing. This all came from our background at working at Deutsche Telekom's research department, where we were responsible for the quality monitoring. And you can imagine that over the course of the years, we did lots of studies with actual human beings where we asked them for their ratings about video quality. And this ultimately led to our contributions in standardization as well, and to a new standard. Well, it's not that new, it's already a couple of years old, but it's still extremely relevant, that allows us to measure streaming quality automatically. And we're going to talk about that a bit more in the next couple of minutes. So the main idea is these traditional QoS metrics that probably most people will know, they kind of fail to predict the video experience. So what we talk about often is hidden problems at a user layer that you wouldn't be able to see if you only did the network measurements. Now, this is not to say that you don't need the network measurements. I think, Claus, with your solution, you're demonstrating very well that active probing and active service testing is crucially important for basic network metrics and to understand if everything's working as intended. But there's a layer on top of that, and the layer is basically us humans sitting in front of a computer or a tablet or TV consuming video. So we want to uncover these hidden issues. And the main benefits, I think I want to start with them because we will come back to that later, but I think it's really important because we often get asked, why would I need to measure that? It's relatively simple. Like Claus mentioned in the beginning, what users actually consume and what they think about is quality of experience. So they don't think about your service metrics. They think about what they experience in front of their screens. So by improving that QoE, you automatically reduce service issues. You get happier customers in return. You have fewer calls to your support centers, and overall less churn. Because let's face it, even though maybe Netflix is the problem, people are still going to blame the internet provider. And there are also lots of studies that have shown this repeatedly. The second important point is that you can optimize your spending, because it seems like we are reaching a point where bandwidth is no longer the primary driver for experience. We used to tell people to get a better bandwidth connection, like gigabit is nice and everything. But when a 4K video from Netflix requires maybe 25 megabits per second, it's not a question of whether you have 250 or 500 or a gigabit available. The problem is more related to peering and how the service works. So you don't just need better pipes. In fact, you can actually avoid over provisioning that and instead invest where it matters, when you're peering with other content providers. The third important point is that you can save time with manual testing. So previously, it would be necessary that you gather customer feedback from service calls, and then maybe at some point you have an understanding of that there's a problem with some service in your network, but it takes a long time, and up until that point, you already have a lot of frustrated customers. If you proactively measure and monitor QoE before, then you already know that there's a problem, And at this point, you already have the data that you need to diagnose the problem further. So you can save like days worth of investigating because you have all the data you need, and then you can directly action based on that. And finally, we see that providers who really care about QoE and customer experience, they can rely on that. They can quantify how much better they are in contrast to their competitors because they can show the numbers, right? They can produce reports that objectively say, my streaming experience is better than X, or we have done the following to improve our peering against these services to make our customers happier. And ultimately, I think that will pay off. Actually, I just had a panel, observed a panel discussion with some Austrian ISPs, and there was, the CTO of a large ISP in Austria saying, like, we're not going to sell people more expensive, more bandwidth connections. What we need to do is we need to demonstrate that we are better at the customer experience. And this is precisely how you would do that. So coming back to this historical perspective of QoS and the other perspective of QoE, the main point I want to drive home is your users don't think about QoS and delivery. They don't think about throughput and latency and ping. They think about how long it takes for a video to load, whether there's any stalling happening during the video playback, or if they're really watching closely, they might see that the video resolution is bad and that the quality is like very blurry. These are things that people are going to notice. So in daily operations and in network monitoring, how do you bridge this gap between the technical parameters and the actual user happiness? And this is what we basically set out to do. Now, to understand these gaps between the actual network health and the user happiness, it's important to understand that you may as well see like the network being totally fine, but you wouldn't be able to see the problems manifesting on the customer side. So, there's this analogy, like it doesn't make sense to check the pulse of a patient with a broken arm. You need to fix something else, right? And the reason why these basic metrics don't tell you the whole picture is that streaming is a very complex application that's on a very high level. And it's not just the video stream itself. The video stream is embedded inside a video player. That, again, is embedded inside a website or an application. And when the player decides to stream the video, it may pull the video from different content delivery networks, all with their own performance and connections. And then how it decides to play the video depends on how it's implemented. Different players have different buffering strategies. They have different adaptive bitrate selection algorithms. And depending on the state of the network, the outcome may be quite different. So basically, the user QoE at the end, it's not a linear function of the network QoS. What do I mean by that? The idea is that adaptive bitrate streaming, as the name says, it's adaptive. So it reacts to the network conditions. And the players can actually trade off the video quality for loading speed. So you might have streaming services that take a while longer to load, but then the quality is also very good. And if there's network fluctuation, the stream may be quite stable. And then there are other players where it's way more important to deliver a video fast. Think about social media, where you're scrolling through videos, endlessly. And then it's more important to load fast than deliver the perfect quality. And for example, two extremes at the end of this scale are Netflix and YouTube. We see that, for example, YouTube is one of the most stable and fastest video services that we are measuring, whereas Netflix takes a bit longer to load. No, but it's also fine. I mean, people are watching movies there, so they may be willing to load a little bit longer. And it has a larger buffer, meaning that if you have a fluctuating network, it may be more resilient to these problems. And then finally, how these services are set up. So where the content is coming from, the peering servers, this has a huge impact. So we've seen that by increasing the time it needs to just fetch the first byte of video data, already the video load time, the thing that users experience, can go up drastically. And you should pay attention to this chart on the right-hand side where we actually did some measurements with YouTube. Now, this is very simplified, but if you think about how long it would take for a video to start, if you decrease the download speed, you might imagine that it's a straight line, but it's not. It's actually becoming worse and worse based on your speed. So that's because the application is just more complex. So just knowing about the download speed itself doesn't really tell you much about the video load time. So that's why we have a better way to tell you what the quality of experience is like. And that is the mean opinion score. This is one metric, one number that captures all these different KPIs and integrates them into a single quality score that reflects what the customers would have rated if you'd asked them. And the nice thing here is that because it's an active automated measurement that basically translates all the data through an algorithm with machine learning, you don't really have to ask the users. So you're not at this stage where you do like NPS surveys or you need the customer support calls. You're proactively monitoring the quality, and you can infer what the customer's happiness would look like already at this stage. Now, the score goes from 1 to 5, and you can roughly translate that between bad and excellent. I added some basic descriptions here, and imagine this to be like a star rating where we take KPIs that are related to the video stream, like the bitrate and the codec and the frame rate, and we can translate them to the mean opinion score. And generally, a score between 4 and 5 is great. Anything below 4 is something where you should already check what's going on. In general, video streaming works well, but when it doesn't, it clearly shows degradations like long startup times or stalling that then automatically affect that mean opinion score. And once you know that there's a degradation, you can go and look deeper. So our recommendation would be to simplify monitoring, look at the mean opinion score, and if there's a degradation, then you can check the detailed data in terms of what goes wrong. Now, to demonstrate that this is not just a made-up number, we're not just guessing. This is actually an internationally standardized recommendation. It's called ITUT recommendation P.1203. And you can be excused for getting that number, but it's the world's single standard for this. So it has been created in 2017, 2018, and it's still very relevant. It's still a good predictor of video quality. It has been used countless times in academic research, and we've seen more and more providers for testing solutions work together with us to implement that standard to really get a unique and global view of the streaming quality. And studies have shown that the performance is quite good in terms of predicting the human ratings, even when you test it with new or unseen data. So it's above 0.80, which is already very good, considering that humans are so different. Like some people might rate the scores differently, but on average, it's a very good predictor that can save you a lot of time when diagnosing these problems, because you don't need to go ahead and check 20 different KPIs for their values. You don't need to check with network technicians to understand like what does a packet loss rate of X mean. You have your mean opinion score, and by looking at that, you can already be very informed about the state of quality in your network. Now, to make this a bit more practical, I want to hand over to Alexander, who will show you a demonstration of how these different services work and how the mean opinion score is calculated from that.
Yeah, thank you, Werner, for the handover, and also welcome from my side to everybody. It's nice to have you here. So I want to start to explain you a bit more about user journeys. So each platform is designed differently, and I took two examples here from YouTube and Netflix, where I did some screen recording while I was connected to a not very fast internet connection, let's say it that way. I have here a use case of YouTube, where I'm just inserting above here in the browser window YouTube URL. It starts to show me the cookie banner. I have to decline the cookies or accept. and then it will forward me to the video. And after a short second time, it will start to play out. And what you can see here, I will just get a bit back in time, is that it loads already the video before the rest of the site is loaded and rendered. Yeah. So the YouTube service is really optimized to to play out fast. I just insert the URL and I want to have an immediate result. As Werner mentioned before, for Netflix, for example, users have a different intention to use this platform. They have a subscription where they really want to see a full movie, and so they are willing to wait probably a bit longer. So I have here also a recording of the Netflix service. In this case, I cannot insert a direct URL of a video that I want to watch. I have to log in first and also decline the cookie banner. But yeah, I can probably fast forward a bit here. Then I get a selection of videos, the start screen where I can find out which video I want to take. And after a while, I found one piece, and then I get some offerings for other videos. So users are, it's a different style how the users are led through the platform, more like an exploring feature. And then I'm starting a video, and I will also go a bit back in time here. I hope you can see it. The video is loading, then it starts. And here there was a short break, so the video was stuttering for a short time. And this is, I mean, in this case, it continued to play out, but this can also be annoying, especially when it's a continuous fragment in the playout. And yeah. You see here this little box, the U. That is because we know from some ISPs that they have their own OTT platform, their own IPTV offering or so. And of course, you also have your own user journey in your platform. And each journey is different. Each platform's desire is different. And so this is what we are doing with Surf solution that I will present now. The Surf solution can automate all kinds of these services. So I shortly showed you the journeys of YouTube and Netflix, and we have multiple further integrations of other platforms, just a few. Especially in the German-speaking area, we have for a lot of local broadcasters implementations. But also here, for example, this is Disney Hotstar, which is the local platform just for India of Disney, or CNBC in the US. So we have different kinds of platforms that we are supporting where we automate these user journeys and interact directly with the web service like a real user would do. And then we select a video that we want to test and hook in our technology into this player of the video and capture everything that we need in order to understand the quality of the video playout and the network. And that can be, for example, as I wrote here, the page load time, just to see how fast took it for the browser to load the overall environment, and then continuous video data, like how long did it then take to load until the video is shown, which resolutions are selected, because as we mentioned, it's adaptive bitrate streaming, so resolutions may change during the playout. Where there's some stalling issues, like I showed you in the Netflix example, and so on and so far. And I will show you a short simulation of this in this video. So we call up these different services in a browser, select the video, it starts to load. And then, as you can see here on the right side, different KPIs of the player are extracted continuously during the playout. And all these data is then transferred into the calculation of the mean opinion score. And this is actually pretty helpful, as when I mentioned earlier. you don't need to understand what is packet loss of X, or in this case, what does video bitrate of 318 kilobits per second now mean for my overall network quality. You just can check out the number. Oh, I'm somewhere here between 4 and 5, and as we learned before, this is a very good indicator. Then everything is fine. If my mean opinion score is somewhere more up in the section 3.5, for example, then I know, okay, there's something where I need to investigate, and then I can still go back into this technical data here and check out what was the exact reason for this, and understand how did the network influence here the mean opinion score. So how do we integrate it with Claus and the pulse score system? So the surf solution itself is bundled into the pulse score system now as a separate module. And you can define in pulse score the measurements that will then trigger surf to run, for example, a Netflix measurement. And all the KPIs that we get from each page, from each service, are then transferred back to the pulse score system. So you get a full set of self-meter KPIs and KQIs to understand your network quality. And how this runs in detail will Klaus explain.
Thanks, Alexander. So if we look at the next slide, so here we have the overall pulse score or pulse score solution. So we have integrated, like Alexander said, we have integrated this technology fully into our probes. So in a sense, it's fully integrated with all the functionality that you as a customer is accustomed to. It's just a new measurement that we configure, and then the probes will measure whatever services that you want, Netflix, YouTube, etc. So it's very easy to take into use as such, and as part of our solution. And you can use it in all of the use cases we have but of course particularly useful for the mobile networks, for broadband networks. We see a lot of broadband networks now struggling just generally actually with active monitoring, running out of bandwidth, as we have rolled out lots of fiber, and the networks get overloaded by the video. So now that it's of course increasingly important to understand what the experience of that video is at the home, so that you know when you need to upgrade capacities, etc., to improve the experience. And you can run it. We have both the virtual probes and the physical appliances. You can run this technology at both the physical and virtual probes. And then we get the measurements into the pulse score, and we handle, and there we add value by integrating these KPIs into all of the existing tools that we have as part of pulse score. So let's have a look on the next slide a little bit more about that. So when you talk about actually what to do with the data, so you will collect a lot of data from different points in the network, and then the important part, of course, first is to set your thresholds. What are your targets for your network that you want to meet? And when we talk about the video, and as we heard here earlier in the presentation, you can basically take two approaches. So you can be very network centric and look at the basic KPIs that are applicable for video. And now again, reiterating, it's not about the basic packet losses, jitters, latencies when we are talking about video delivery, because of all the buffering and the way that this video is delivered. When we're talking about video, basically three KPIs that Werner already went through. So it's really the initial loading delay, which I think all of us can relate to when you are waiting for that video. It's really annoying if you have to wait a long time before it starts playing. And there's some research out there that 2 seconds or 2.5 is kind of the times that you are willing to wait for a video to start playing, and if it takes longer times, some of you will start to look for other streams, and I've seen some figures like if you wait for 5 seconds, it can be up to 50% of the viewers that start kind of to get annoyed and look for other streams. But as we also touched on here, it depends also on content. If we're talking TikTok, social media, that those thresholds are probably smaller. Now, the second KPI is really about stalling counts. When your video freezes as you are watching the video, and you have to wait a few seconds for it to rebuffer, fetch more content, that's really annoying as well for the viewing experience. Even if it happens once during a movie or series, that's truly annoying. And if it happens multiple times, we have similar research figures that you can have up to 50% of viewers again starting to abandon the streams if you have more than three stalling events and so forth. Now the third one, which we also touched on, quality, adaptive bitrate. Streaming is of course made such that if there's not enough bandwidth available, it would switch it down to a lower quality and resolution. And again, if you have a 4K television, that's really not nice if you are watching your Euro football and it goes to a lower quality. That's truly annoying as well. So these are really the three basic parameters. Then there are other factors that then these ITU algorithms take into account. And I can tell you, I have looked a bit on the specifications. It's quite impressive formulas that have been made. And like Werner touched on, it really is a really nice correlation with what the viewers would actually rate the services. So this is the first way to approach it. There are good bases for where you should set your thresholds, but as Werner was suggesting, I think also when we are talking about quality of experience, the mean opinion scores that are calculated is the best way to set your initial thresholds to really understand. And there are good threshold settings where what you should target. There's something from the ITUT specification. It's a little bit engineering. I actually like the Werner's categorization better. I think 4 is something that's very good to keep in mind. Everything above 4 is good actually, and when you start going below 4, it quickly erodes. So already 3.5. You could think of if you get down to a MOS score of 3.5, then you already have serious issues and you should take action. So your target should probably be at the 4 or somewhere very close to 4, what you are monitoring. And this also allows you now to put your attention where it matters the most. The first thing is of course, from a network operations point of view, is to have that real-time view of what's happening in the network. And that's what we do when you have set your thresholds. We will map those thresholds into events when our thresholds are crossed. And then you can see in your map view with a traditional green, yellow, red coloring, where in the network you have the issues. And this can be quite helpful actually already in terms of correlation. If you start to see it in a specific region starts to be red, and then you can suspect a more systematic issue, more central in the network. Whereas if you only see a particular measurement being red, it's probably more of a local issue closer to the customers. Also, of course, we store the events, we export them. So typically you will have your umbrella event monitoring solution. You don't want to look at the maps all the time. You have your umbrella event monitoring solution. We export the events there. You can react to the events there. But then when you start to look, and we also keep the history, so you can also go in and look at the historical events. You can find trends. You can look at did I have a similar issue yesterday? How about the day before, a week before? Is this something that happens only in the nighttime, evening time when there's a lot of viewers, or is it something that happens throughout the day, and so forth? And by that, doing good trend analysis on root cause analysis of what the issues could actually be. The second level, so to speak, is now that you have your big network, you are measuring from a lot of different points in the network. The next step is then to aggregate this into dashboards, and we have very flexible dashboards where you can aggregate all of those measurements and how they perform against your targets. So I can see in one view. I can summarize it from different perspectives. Maybe I have an overall view of the whole network and all the streaming services. Maybe I have one dashboard showing the Netflix performance, another one for YouTube, a third one for the other streaming services, for instance, maybe some regional dashboards that will show the streaming performance in certain regions. And I can, of course, also mix and match the streaming performances with other sorts of active measurements to have the full view of the network from different perspectives. I can also enrich these measurements with metadata, which is then really helpful in terms of accelerating the root cause analysis. So I can put in information about what access rings are being used. Am I using radio links, for instance, as part of my service delivery? What peering arrangements are relevant for these particular measurements, and so forth, so that I can very quickly do the root cause analysis and understand the context of that measurement, how that relates to the overall network, and correlate then that when I look at my measurement. So that data will be also available then as part of the measurement data when I look at my dashboards. So then the next level really is, and what we are seeing maybe today is when you really want to form a bird's view, and we go to the very proactive mode, is not only to look at, let's say, the situation today summarized, but actually summarize that over a longer period of time. And we have for a long time had this service level agreement calculation engine. It will actually continuously take all of these KPIs that we collect, in this case for the streaming data, and based on that calculate availability. So I can understand how much of the time did my streaming service actually meet my targets during the last day, during the last week, month. And this is, of course, very helpful in terms of seeing particular trends. I can compare this week's performance with the last week's performance, see if I have some particular locations in the network where the streaming performance starts to degrade, and then take actions before actually the customers start to notice this degradation of service. And we are also seeing a lot. Initially we made these SLA reports for external reporting, but nowadays, because of how important the quality of experience is, the CXOs start to want these reports of okay, so how is my network doing? How are my customers experience my services? And again, this regular report based on the mean opinion score is really spot on for executive reporting. It tells in a very easy to understand way how the network is performing. And if I say the initial loading delays is 3.5, that's really not going to tell to a CTO whether the network experience actually is good or not. But the mean opinion score, everybody knows it. It's familiar already from voice-based services. So it's really a nice KPI also in this respect. So, well, that's all we had in terms of slides for today. But I wanted to take the opportunity to also discuss a little bit more with Werner and Alexander. And of course, please, if there's any questions from the audience, please ask that as well. Let me see.
Yeah, we do actually. We have two questions. So there was one that came a bit earlier. So maybe I'll just pick that up.
Yeah, sure.
So the question is, does the experience not depend on where the content is stored? So if there are a lot of downloads, the content will be more in a hub close to the edge. What our opinion on that is. And
right.
In general, I think that is definitely the case. So more frequently used content should be cached closer to the user by the respective streaming provider. So if you want to watch a Netflix movie that everybody else is watching as well, you would hope that Netflix stores it somewhere closer to you geographically than something you dug up in the catalog from way back. Right. And I think this is where we see the biggest optimization potential for internet providers combined with these types of measurements, because we can trace where the content is coming from. So we can see for each measurement which Netflix server has been used at which IP address, and obviously where is that placed. And in particular, Netflix is a good example because they have two types of caching or peering. They have their regular peering servers that are connected to an internet provider through regular peering exchange points at internet exchanges. But they also have on-net caches, which are appliances, like physical hardware that Netflix ships to you for free. So you can place it inside your network. And by doing that, obviously, the quality will be much better because, like we said before, the time to first byte of a video will be drastically improved. And by that, also the loading time of the video. So these are like the biggest optimization potentials you could have by improving peering, especially when there's a chance to deploy caches closer to the user.
Right. Really interesting. And we had also another one. Does the user experience also depend on the equipment used by the customer? Like you can guarantee the quality to the entry point of the home, but not everyone will to a movie on a PC and TV have very often their own browser and memory spec. So when you watch a movie on a mobile, it's a completely different experience and setup. User experience is a network point you cannot control to the home network. Do you agree? So I guess question, you have a lot of devices at home and with different specs, etc., and Wi-Fi, etc. So how do you comment on that one?
Alex, you want to take this one? Or?
Yeah, I think we have to differentiate. So the idea is that we want first to understand what is, let's say, the reference quality of the network itself. When you already have issues in there, you don't have to check out which device is my customer using, because he won't get a good quality anyhow, no matter which device he's using. The other idea is exactly that devices can behave differently, but in this case, it's more like we want to see what is the best quality that we can chip to the end user, and what is the best signal that he can get that his device will use at the end. And we did a lot of integrations also for other devices. And I mean, when they're not super outdated, most of the modern devices are super capable to give a good experience. So maybe Werner, you want to add something?
Yeah, just an observation I made at a recent conference or exhibit where there was a lot of focus, of course, on customer premises equipment, like user Wi-Fi routers, basically. And of course, I think it's fair to say that, yeah, the biggest source of problems at the home are probably not just from the internet provider, but also just from poor Wi-Fi setup.
Right.
But it makes that all the more relevant to have a baseline measurement, like Alexander said, if you can prove that within your network and for different reference points, everything is in order, then at least you don't have to do that expensive troubleshooting again and again. Like if you get reports or you get tips about bad performance, it would be foolish to always look for the problem on your end. So I think maybe taking a more general perspective for internet providers, it's also often very relevant to find out who's to blame. And if you 100% know that your network is not at fault, that's also information that you can use to better help your customers.
Yeah, absolutely. I guess that's the point, right? We have a really consistent measurement. So we kind of take Wi-Fi out of the picture, which accounts for many of the issues at home. And maybe also one thing which I think was really nice in Alexander's part. So with your software, you kind of automate that user journey, and it's always done in the same way consistently. So like you said, YouTube has optimized to deliver video very quickly. It will cache something in the background, etc. So if I would do this manually, I would actually get different results each time, right? Because it will depend on how quickly I was actually able to type the video and start playing it, because YouTube would have then cached a bit at the beginning of that video, and so it would start to play instantly, maybe if I do it manually. But here, when you automate it like you do, it's always going to be consistent. It's going to be very quickly walk through that user journey, and you're going to get the same result every time. Right. It's so that's really good. So okay, I think we had another one. Can we decide the cause of problem, allocate the exact location in which device in the user network in home or office, and how this can be done? I guess, well, basically how to root cause and find out where the issue actually happened. Is it at the home? Is it how to find what is the cause of the issue?
Yeah, so I think it's important to explain the type of monitoring that we do, and that also is the PulseCore platform at the core of it, which is that it's an active monitoring system that relies upon representative placement of monitoring devices in strategic locations across the network. So, for example, we work with a content delivery network provider who delivers video, and they place their probes at different locations, for example, really like physically next to the place where they produce the video segments or store them. Also at different internet exchange points where they deliver their data to the different ISPs or other peering partners. And they also have probes at user homes. So these would be maybe employees of that CDN provider who have a small box at home doing the measurements. And by that, you can see where the source of the problem could be, because, if it's fine in one area, but then suddenly it's worse when it reaches that particular ISP, then you know where the issue is. Now, of course, this doesn't tell you the story for every single customer, but that I think is a more general question or problem of the industry that is still not answerable, because it's also a huge data privacy question. You couldn't possibly measure what every user is doing, in particular on their devices, also considering encryption, etc. So the best you can do, I think, is to just attempt to be as best as you can, as detailed as you can with your measurements on strategic points. It's certainly possible that then users will still complain or indicate problems, but then it's way clearer that this could be related to their equipment only, and not to a general service issue.
I think we can add the success story we had recently with broadcaster, where we measured in the network that a certain broadcaster started to have some quality degradations, and we observed a lot of stallings in all reference points in the network. And so this was an issue where all people using the services and these internet connections were somehow affected. And it is interesting then to see what is the root cause for this. And in fact, it was that this particular broadcaster was using a multi-CDN strategy, and depending on the CDN that they were using, we observed different quality values. And so in this case, we dig deeper and debugged what is the issue that this broadcaster has, and in fact, it was a correlation between some player implementation and the CDN usage that raised these quality issues. But the user at home is just sitting in front of the TV or a computer or a smartphone. And in this case, it doesn't depend on the device. It is really that this combination between network-based components and software-based components created a bad experience at home. And me as a user who's unexperienced and doesn't know all about this, I would just say, something is wrong today. And if I probably have often this issue, I would say this is my provider. And when my provider says we don't see anything, everything is fine, I would be unhappy and think if I would probably go to another provider. And so with this collaborative approach and finding out what was the exact issue of this broadcaster, we were able to help them to recover their service and finally make the quality of the play out better or back to the original state for all users using the service and these internet connections, so all over the whole country.
Oh, that's
And one
really
last point to that, the only reason that was discovered is because the ISP did the measurements and they wanted to make sure that their customers got the right quality.
right. Yeah, exactly. Right. And is this multi-CDN such that I, as a user, it could select another CDN for me at the next time I'm viewing some video, or is it more like location based or somehow?
So the multi-CDN topic is, I think that's something that came up a bit more in the last couple of years. So providers have realized they need redundancy or they need failover
Right.
to serve their users better. And the way that these servers are selected is mostly done based on pings. So these are like latency measurements where they have like at least a heuristic that says, from the user to my different content servers, I look at the different pings and I typically select the fastest one or the one that's not already having too much traffic.
Right.
But it's also a cost issue. Some CDN providers are just cheaper and may not perform as well as others.
Right. Yeah. And it's a complex function of how loaded that CDN is at the moment when I start playing, and what the network how quickly the network responds, etc. So okay. Now there's another question here. In case users using VPN, if you are using IP VPNs, level 3 VPNs, can you reach their actual IP network? That might be. Do you see? I guess the VPNs would be more for business services typically, but have you seen any usage of VPNs in your
So
customer deployments?
yeah, it depends a bit on how to interpret the question. I think if it's about what like end users are using, then obviously we don't have that insight. It's also because the way we do active measurements, it's really not related to a single user's usage.
Right.
That being said, and I think that's a topic that we didn't really discuss a lot, but there are solutions that claim to passively monitor streaming quality and that they would also handle encrypted traffic and maybe VPN traffic. I don't know. We are not strong believers in that because of the differences in services that we just explained. So if people are using VPNs, then obviously internet providers have next to zero knowledge about the quality that they're getting.
Right.
But you mentioned the business use case. I mean, obviously, for enterprise settings or businesses, this type of monitoring could also be very relevant. Think about, probes that ensure service level agreements where in a stricter setting where the business requirements are just more important, or the fact that we could measure proprietary streams or internal video streams, or let's say, I don't know, broadcasts of internal presentations or things like that. So
Right.
our solution is not just limited to public or OTT providers or social media, but also could measure any stream in
Right.
combination with the network metrics.
Right. So maybe just to step back a little bit on a general level. So if you not just want to summarize, we basically went through, but why as an operator, so why would I want to deploy this quality of experience monitoring solution? How do I get my money back on the investment?
Yeah, I think it's something that sometimes is harder to put into numbers, but the general perception of the ISP is something that definitely matters in terms of what customers are willing to buy. I talked to a representative from an Austrian ISP just 2 days ago, and he said, even though our basic operational metrics are fine, when we talk to our customers, they always say, it's the whole experience that matters, and the thing that people are noticing at home is the application that they're using. So it's mostly about what happens or what doesn't happen when you want to watch a video, and to minimize these kinds of frustrations, because in this hyper competitive landscape, it's very easy to lose customers who can just select a different streaming provider, which may even end up using the same physical fiber to the home. But the routing behind may be completely different, or it's the whole packaging of the ISP that makes such a strong difference. And the same guy also said, people aren't willing to spend more money on internet services, but they are willing to spend more or choose the provider that has a demonstrably better UE. And that's, I think, where that comes in. Yeah.
Good point. And so, okay, now I decided to invest, and I have my solution. Now it shows I actually have some bad quality of experience in some parts of the network. So what can I do?
Alex, you want to take this one?
I think that is what I yeah, just roughly drafted with the story I told before. So when we have the mean opinion score and we see that it somehow declines, we want to understand why does it decline.
Yeah.
So and we, as I told before, we have all the data that is relevant to compute the mean opinion score, but also the surrounding metadata. So we can investigate, for example, okay, the mean opinion score is now worse than usual because the initial loading delay increased, or we get multiple resolution switches, which can be really annoying to an end user. And then we want to understand, okay, why is that so? And then we can see, okay, what are the, for example, how were the requests structured in this measurement? Where there are some certain CDNs involved, from where did these requests come? And so we can look on a network level, what is the issue, or where is the root cause? And then we can check if this is something an ISP can fix. And if not, it's at least in this moment a help that you can say, okay, it's really not to us. And then you can decide to discuss, for example, with the OTT provider, hey, we found an issue. We measured you. what can you say us about this? What have you have you done some releases in the meantime? I mean, we captured the metadata, so we can also see that, for example, some player version might have changed or so. This can be relevant in this case, that you already see, okay, they changed the software or so. Sometimes it's easier to discover, and sometimes it needs a bit more deep dive.
Right. And I think Werner said also that, for instance, with Netflix, you could even maybe talk with Netflix, get some caching server closer
Yeah.
to the customer and so forth.
Yeah, I mean, it's all about relationships, right?
Yeah.
If a network provider wants their users to have a better experience, they have to, first of all, consider that if there's a problem, users are most definitely going to blame the ISP, even though they may not be at fault. So knowing that you are not the problem is the first step. And then
Yeah.
second of all, knowing where the problem is and then being able to contact the application provider. And we've seen cases of that where that definitely helped. You could go to Netflix and install these applications inside your network. You can go to a broadcaster and work with them and say, here's this data that we have about possible service issues. Let's work together to improve the quality of experience for both of our customers, right? So that's definitely a solution. Yeah.
Okay. And also peering and stuff like
Yeah.
that you can change peering agreements. And well, what about then? So I really like the graph where it says that, you know, the quality of experience is not really linear to the quality of service quality. So is there some example where you could actually say that that optimizing something in terms of the quality of service would actually impact negatively the quality of experience?
Yeah. It's so for streaming, it's it's two sides of the same coin. It's you can optimize the latency versus the resiliency. So live streaming, that is. So imagine you're watching football and you're watching it through your laptop or on TV through an app, whereas other people might watch it on a satellite connection, and then they will cheer earlier than you if there's a goal because OTT streaming has just so much more intrinsic latency. To combat that, OTT streamers are trying to bring that latency down. So they want to instruct the player to be closer to the live edge. But by doing so, they decrease the buffer size. And what happens then, if there's a network issue, is that you run into stalling. You just get the reloading spinner. And that's super annoying, of course. So you have to make a trade-off there. And obviously, this is something that's more in the domain of the OTT streaming providers, but they do need a good understanding of what are the bandwidths and network conditions that they need to work with to deliver the best experience. And the only way you can really tell is by performing these kinds of measurements.
Right. And how about if we dig a little bit more, go one step lower into the adaptive streaming, and is there anything, if you are not looking at how you improve network or the CDN and peerings and these parts, is there anything on adaptive bit rates or player implementation, something like that you should take into account in order to create a better quality of experience? Something that you can do on that side.
Yeah, I think Alex mentioned it before, right? If the OTT providers implement new player versions, they might break something and they don't know.
Right.
We've seen this happen before. Obviously, that's something that also is not the responsibility of the ISP, but we have seen cases where the ISP detected these problems and they could be resolved together with the streaming provider. So yeah.
Yeah,
it's definitely always the question of who's at fault, right?
Right. Yeah, and that's very interesting because we have kind of similar experience from active monitoring. Maybe if you do a firmware upgrade to your network devices, then our solution actually really good kind of verification device to look at the measurements before and after. So I upgrade my firmware for some routers. Do I see more delays, packet losses after the upgrade generally as a trend versus before the firmware upgrade? So I guess that player firmware upgrade, so to speak, is the same thing. So something changed
Yeah.
In this case, we don't even have control over it, but we still need to have the visibility, right? To maybe talk to the provider to do something about it. All right. So what we talked a little bit about the mean opinion scores and talked a little bit about. I think it's kind of interesting to use as an internal reporting tool also within the operator organizations. Is that something you are seeing within your customers that they would use it for internal reporting?
Yeah, I think the people that we make most happy are the people who have to report to their managers that everything's in order.
Right.
So the mean opinion score is a nice way to do that because it's easily understandable. It doesn't require a lot of thresholding and KPI analysis. You can just put it in your Excel sheet or your report, and it should be understandable. Yeah.
Yeah. All right. Okay, I can see we are a little bit actually over time already. So maybe to conclude this panel discussion, so can you give some real world example on how a company could use this quality of experience data to make better business decisions?
Yeah, Alex, maybe, or
Yeah. So it really depends. So probably we should conclude with a nice quote of one of the engineers we are working with. He said when he launched our software and was investigating more on the network, he said, "Finally, I can see all the parameters that I need to optimize. And before I was always digging in the dark when I heard that something isn't working, and now I can really see what happens when I tune parameter X, and yeah, what is the effect in the end."
Great. Yes, really good to conclude with that quote. So just in conclusions, like we talked here, now when it comes to video, social media, packet loss jitter latency is no longer sufficient to capture the video performance. They are not directly related. And now by simulating this user journey and automating that, we can correctly capture the important KPIs for the OTT video and social media. And when we are talking, what are those KPIs? Initial loading delay, pre-buffering events, video quality switches are the main KPIs that give a really good capture of what the video quality is, what the user experience of that video is. But when it comes to the best KPI, we talked a lot about the mean opinion score. That's really a solid, and there are solid formulas and behind it to capture the user experience in an understandable way. And of course, by doing this, we really get from a reactive mode. If you are waiting for your customer feedbacks, you're going to be weeks off before you actually notice that you have an issue. By deploying these measurements, you can actually start to see these issues before your customers starts to notice them, and you can see it from the reports, from the trends. That you are having issues. As we talked, there are many different things that you can do proactively to then fix it together with the content providers, and to really, it's also about having the visibility in terms of your network to understand that does it make any sense to invest into this network to have more bandwidth, for instance, in certain locations. Does it actually have any effect on how the users are experiencing the services, or should I perhaps invest in something else, maybe actually to deploy some Netflix caching servers or peering agreements? Maybe the solution is somewhere totally different from what I thought about. All right, that's all we have for today. If you have any questions, so here are our email addresses. We're really happy to just approach us, ask questions. We are happy to arrange for a proof of concept of the solution to demonstrate the value. Please visit both the Creanord and AVEQ websites if you want to have more information, and also check, as mentioned in the beginning, check our Creanord website for the previous webinar topics if you want to look at what we have talked about before. So that's all for today. Thank you for joining, and thanks Werner and Alexander. Very interesting discussions.
Thank you, Claus, for the invitation.
Thank you.
Thank you. All right. Thanks.
Bye-bye.
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 Bye.